A continuación, invito al señor Eric Bruggeman, CEO de Bruggeman Consulting, para dar inicio a su conferencia. Es ingeniero mecánico e ingeniero de sistemas y de calidad, con especialización en gestión de empresas. Ha sido gerente de proyectos ambientales de NIT PISOT y ha desarrollado el diseño de la preproducción de Rockite y G6, vehículos a su vez que elaboró como ingeniero de proyectos en Gillette S.A. Un fuerte aplauso, por favor.
Good morning, ladies and gentlemen. Thank you for the opportunity to discuss the environmentally friendly gold, silver, copper extraction methods where we can extract most minerals without using any chemicals, any mercury or any cyanidation or any other chemicals that we do. I just need to be able to see. So we call it the green extraction technology. And what it really means is extracting technology or extracting minerals without the use of chemical. This is designed in South Africa. It's taken over 40 years of research and development, test and trial to get to this technology where we are today. And it is based purely on the specific gravity of gold, silver, copper, platinum, or any other material that you want to do. I will show you a picture just now, and then I'm going to show you a schematic layout, and we'll go in detail through there. Obviously, this is a fully 100% manufactured product in South Africa, and I've just spent the last 2 years in Ecuador. If I'd known what Ecuador was like, I would have come to Peru and did the tests here. But we've tested in every possible mine, from alluvial to gold mines, mines with silver, and the results we found was absolutely extraordinary. The one product I'm talking about today is the PET 4000. It's a 4-ton per hour plant. We have other plants that we've designed for the small alluvial guy that can do up to 1 ton per hour. We have plants that can do 20 ton per hour, and our biggest plant that we make is 100 ton per hour. And the 100 ton per hour we're using mainly in Africa, and one of the ones that we use is for diamonds. So this machine has a head feed of up to 4 ton per hour, which is ideal for the small, medium size mine. This machine is not designed for the Anglo-Americans or the BHP Billetins. This machine is designed for the small miner that owns a mine and that pulls out between 40 and 100 ton of ore per day. It works basically on water and water pressures, and with the SG we play and we balance out water with flows and the specific gravity of a certain material. We don't use any chemicals, so it's really a nice product. If you look at this flow diagram in front of you, you'll see there's 2 sections to the flow diagram. Before I get there, I'm going one step further, and that's what the 4-ton per hour machine looks like. There's 5 compartments to it, 5 specific compartments, very specifically designed, and the IP lies in the hydraulic separator. The rest of the equipment is pretty much standard available throughout the world, and you can add onto this and you can take parts of the equipment off. This particular one is a fully mobile. All our machines can be mobile. This particular one is mobile. A normal vehicle, 4x4 vehicle, will be able to tow this. I've gone through the Amazon with this vehicle several times, and we know that it stays on its wheels and it works. And the basis of this, the basis of this is where you get a pile of ore. You can put it through as alluvial, in other words, the stone where we wash the sand off, and the sand becomes mud, basically, when you mix it with the water. The machine takes 4,000 liters of water per hour, and more than 50% of the water is recirculated. And it goes through what we call a scrubber. And the scrubber works on the basis that where you've got rock and sand together in a screw conveyor, which is a double screw conveyor system, the sand and the rocks will mix, and it will crush a certain percentage into a finer mud-type liquid. It will then discharge out of the scrubber, but in the scrubber you have your first discharge. So all the soil that is light, with the motion of the screw conveyor, because it turns at a certain revolutions per minute, your first discharge of mud water comes out the back of the scrubber and will go into a tailings dam. The balance of the product, which will contain your copper, your gold, your silver, or any other elements, will be driven up by the screw conveyor onto a vibrating table with high-pressure washers. That vibrating table has got screens, normal screens, which will allow the material that's smaller than 5 millimeter to pass through. The balance of the material will be discharged into a discharge chute, and at the end of the discharge chute, people can put a different table to receive if there are any gold nuggets or anything smaller than, or bigger rather than 5 millimeters. All the product that is smaller than 5 millimeters goes through a hydraulic separator. And this is where you have a pulsation of water, where you have a water pressure going up and down. In other words, it's pushing and sucking, pushing and sucking. And in that process, you will have your gold, silver, copper, or any other element that will be pulled down because it's heavier than the water or than normal sand. And that will then go through into 2 cyclones, where your cyclone will separate your fine gold. And the screen size, depending on the type of ore that you have or the soil that you're busy putting through, we work between 300 and 200 microns that will go through. So your gold particles, your silver or your copper is very, very fine. This will go through 2 cyclones and will be separated where the heavier parts, because of your SG, your specific gravity of your material, will go through the cyclones into a concentrate bottle. Now, all the miners, or the alluvial miners, or the small miners, they work with fines of about 120 micron. We have found that the microns we get through after our process ranges from 18 to 120 microns. So it is really, really ultra fine. Once we have a concentrate in the concentrated bottle, you remove that and you can put it through a furnace. And this is for free gold. The free gold, once you put it through the furnace, you will end up with a dory bar. You can then measure the percentage of gold, copper, silver in your dory bar, and from there you can take it further to a refinery. In the process, this plant has got 4 discharges. So your first discharge ends up from your scrubber. Your second discharge goes through on the top of your vibrating hydraulic table and goes into an auger. And the auger will move that material to a third discharge, and your 4th discharge will come through your cyclones. Those 3 discharges all come to one point, and that will go to a tailings dam. Now, the question we've been asked many times before is, this plant will only work for alluvial gold? The answer is no. If you have encapsulated gold, we have found with all the experiments in Africa, we got these machines in 7 countries in Africa, we got them in Canada, and we got 3 machines in Ecuador, is that where there is encapsulated gold, we will collect the encapsulated gold. The question is, you have 7 or 8 different ores that contain gold. You then need to find out what ore, what specific ore you got. Is it an arsenic-based ore or whatever ore base you have? And then we can design the process, either through baking, through flotation, or through cyanidation, or any other way to extract the concentrate gold. The advantage of this machine is that because you end up with a very high percentage of concentrated product, you do not need a big flotation plant or any other big flotation plant or a chemical plant to take out the encapsulated gold. You are going to catch the free gold, and through the furnace there's certain rock ore that will burn away, but there is the arsenic and other rock types which you have to then put through a further process. The advantage of this is your tailings can be bagged, and a lot of miners bag the tailings. Instead of putting it into a tailings dam, you bag the tailing. But we do, in Ecuador, we've put up a complete environmental system where we draw the water, the 4,000 liters of water we require, put it through the machine, pump it into the tailings dam, and then siphon the water off, pump it back to the reservoir. Because there's absolutely no chemicals being used, we were the only tailings dam in Ecuador that had frogs, a population of frogs, because there was absolutely no mercury, no cyanide, no chemicals whatsoever. For a certain of the mines, if you're not doing alluvial mine, you'll see the first part of the graph, there's a pile of sand. We also design the crushers and the mills to bring down the rock or to crush the rock. And where most people go wrong is they try and get the ore or the crushed rock as fine as possible. In other words, they're trying to get it between 80 and 100 microns. Some people even want to go down to 50 microns. And in all our years of experience and tests that we've done, it is most advisable that if you are taking ore out of a mine, to analyze the ore, to find out what is the size of the particle of crushed ore that you need. Because most people that crush too fine end up that all their gold, silver, and copper is lying in the tailings, because gold actually floats. And we use a special soap powder and a fertilizer to get the gold to weigh a little bit more so that it doesn't float and it sinks. And we found that when you're crushing on a mine, in other words, you're taking ore out of a mine, it's not alluvial, the best is between 80 and 120 microns for crushing. And those are the best results we get out of here. This equipment, I think I need to go just one back, one forward. That machine. We put on this machine, as you see that machine standing there, we have, you can feed it with a spade, you can feed it via a conveyor belt, you can feed it with a conveyor from a crusher from a mill, and where we do tailings, because this machine has found many more uses than just alluvial. In Ecuador, we found on average that the tailings dam contains 17 grams of gold, which in their process they lose, and we've reworked the tailing dams, and we're getting between 80 and 85% recovery of the tailing dams through this machine. And you can pump the tailings in, you can put dry tailings in. It comes with a generator, and the reason why these machines, even the big machines, come with a generator, we found in South America that the power fluctuation, although they run 3-phase 440 volt, on some of the mining areas, the power fluctuation goes from 220 volts to 500. And if you haven't got electronic protection on all the stuff, you damage it. The other, because it's mobile, people prefer to have their own power pack unit on there. Ideally, this for Peru would be to get the government interested in something like this, because the miners that are using the mercuries and all these other chemicals to extract, whether they're going through a chancha or whether they just burning it with mercury, they don't always have electricity and they have got water, so it's a nice way of doing this. Then we have a lot of extras that we fit in Africa. For example, we put tracker units on these units. We can put weight scales on, we can put flow meters on. There's 100 different added extras, but we try and keep the basic machine as cheap as possible so that the small miner can afford to use this kind of equipment. It is totally maintenance free. A hose pipe you can wash it down with. You don't really need spares. And all the equipment that is used on this machine is readily available in every country. For example, WEG motors, bearings and everything. So you don't need from South Africa to supply spares to a product like this. All the electronics is WEG or Siemens. So it's really a compact machine. It comes complete with a pump. So the guys just need really to find the place for where they need to get their water. It weighs 2.5 tons. It fits into a container. The crusher unit that we supply with it as an additional extra also fits into a container. So it's very easy, very removable, and you need 2 operators to operate a machine. If you're feeding with a conveyor, a 4 ton an hour sounds like a lot, but it's not actually. It's something like 33 kilograms a minute or 330 kilograms a minute, so it's not a lot. People don't sweat, and you have somebody to control it. In Africa, we put on a lot of safety equipment because people tend to operate the machine, and when they find gold, especially alluvial gold, free gold, they seem to want to keep it for themselves. And wherever you can find gold, we have got as a lockable container so that you can't get your hands into the machine to extract the gold yourself once you have found it. The record that we have found in Ecuador on a ton of material that we put through this machine, and it wasn't totally free gold. We used another baking process after it before we put it in the furnace. We found 102 grams of gold. One of the remarkable things is we have found every element that a person can find, and people really need to understand the soil or the mine type that they're using. It is not a machine that creates gold, but it will extract gold. Thank you very much. We are on the stand in hall number 1 on the South African stand, if anybody wants to come past. We've got an incredible amount of photograph and film footage, which obviously I'm not going to put up here today for anybody, but you can come and talk to me. We have got more details. Are there any questions? I thank you very much.
Una de las preguntas es, uno de los problemas más grandes de la minería informal, que son los mineros artesanales, ¿cómo ayudaría el proceso y el equipo a mejorar la calidad ambiental y la salud de las personas que hacen la práctica informal de obtención de oro?
Thank you. Yes, it is very easy. The people that use this equipment how does it change their life? The normal process or the normal procedure of extracting gold or silver or copper from ore, if you're not part of the Anglo-American group or part of the BHP bulletins, or you don't have a massive mining operation, we found through research that 60% of all the gold that the people spend a lot of money extracting the ore out of the ground through their process, whether it's through mercury, whether it's through panning, whether it's through chanchas, whether it's through the chili mill or whatever, they are throwing approximately 60% of the gold away. And out of that 60%, 40 to 45% is the fine gold. So most people find the nuggets, especially if they're big nuggets, but when you're talking fine and extremely fine gold that's 80 microns or less, the small miner or the alluvial miner cannot recuperate that. So how does it change somebody's life? It is simple. He is going to, this machine has between 85 and 95% recovery rate. So he is going to get 35% more gold using this equipment than the equipment that he is currently using. If you take the price of gold, that is an incredible amount of money. And we have seen with the experiments that we've done, where people get 12, 13 grams of gold per ton, they're getting up to 45, 50, 52 grams of gold. That makes a huge difference to a small miner that is every day mining. The other thing that if you work out the costing, that how much it costs him to get a kilogram of soil or a ton of soil out, what it costs him to process it, and how he processes it. The guy that is doing, if he can get 12 grams of gold and he can increase it to 48 grams of gold, the difference in gold price pays for the machine in less than 3 months. And it has, we've seen, it has made a huge difference to the people's profitability because you are not throwing gold away and you are only processing something once. Thank you. Okay. Yeah, it is 100% possible that you, in your, where you got your hydraulic separator to your cyclones, you should not lose any gold. And the reason for that is because your pressures are set up front, you know what ore you've got, you know what you're crushing, you know what you're milling. And what we do with most people is test the ore before, so we know what amount of gold to expect. Once the machine has been set, the machine will do the rest. Where you start losing gold to tailings is if you increase the flow of the water. In other words, the gold hasn't got a chance to settle either in your hydraulic separator or in your cyclones. And if you put too much pressure through your cyclones, you will wash a certain amount of gold through, which will go to your tailings. So the principle of this machine is if you set it correct, you will not lose any gold through to the tailings. If you've got encapsulated gold, I guarantee you, you will lose your gold to your tailings. But once you know what rock you're working with, we can limit that by putting in an additional screen table before the tailings dam. But with encapsulated gold, it is incredibly difficult to prevent 100% of the gold because you don't know what percentage of gold is encapsulated in the sand. And if it really, the machine works best with anything of a specific gravity over 2. So if you've got very fine particles of gold in the sand and that the weight difference between the gold and the sand is less than 2 or 3 specific gravity, you will lose gold to your tailing. But on free gold, or silver or copper, you will not lose anything through your hydraulic separator, and you will not lose anything through your tailing, through your cyclones into your concentrate. Thank you.
Agradecemos la conferencia del señor Eric Bruggeman. Thankful for your conference, Mr. Eric.
Thank you for having me. It's a pleasure.